Dr. Hussain Bakshiola ji YouTube channel is saying good afternoon to you, and we are just in the community medicine lecture, and we will discuss the level of significance or test of significance and testing of hypothesis, as well as we will have type 1, type 2 errors, parametric and non-parametric tests, and a little bit overview of all these topics. So, next please. These are the learning objectives, and you can see that what are the statistical errors, what is the importance of the statistical errors, type 1 error, type 2 error, and even now type 3 and 4, but we will not discuss. Next please. These are the levels of significance in which null hypothesis, and the level of significance is probability of rejecting the null hypothesis in a statistical test when it is true. So hypothesis should be true, and statistical test should have a data which can reject it. Then that is important aspect of significance. Null hypothesis we will discuss H naught, and even the alternative hypothesis. Next please. So coming to the change the slide. So there are two situations in which decision made on the data in statistics become wrong. These are called as errors in statistics or statistical errors. So these are basically the calculation errors. Calculation, the data collection methods, and even the analysis is not properly done, then you can have these type of errors, type 1 error and type 2 error. Yes. So type 1 error is basically when the null hypothesis is true and you are rejecting it. So that is type 1 error. And type 2 error is when the hypothesis is false and you fail to reject it. That is the type 2 error, and we call it beta error to type 2 error, or it is equal to false negative, and the type 1 error is the false positive in screening test or in a normal life. So next, type 2 error I have already discussed. Next. Yes. So you can see that suppose the story of the wolf, in which the wolf was not present or present. So in both scenarios, the elk was called and the wolf was not present. Then we went to the elk, and it is a false hypothesis, and we should fail to reject. And if we reject it, then we are making correct decision. And in the type 1 error, the wolf was present, and we could not actually reject, we could not identify the wolf is present. So in that case, the null hypothesis can be true, and we may reject the null hypothesis. So in this situation, it is a practical situation, and I will say to my camera, please, if you put below and there are two tests in which suppose a report says that a pregnant lady is not pregnant, and even a male can be shown as a pregnant. So these are, and you can see that when the false positive is considered as a true thing, or you reject when the null hypothesis is there, then we are causing or we are making type 1 error. While there is pregnancy, but our test or our observation says that there is no pregnancy, so it is a false, and we fail to reject it, then it is type 2 error or false negative. Next please. Difference between type 1 is if null hypothesis is rejected, that is actually true. So when you reject the true null hypothesis, it is type 1, and when you fail to reject the false hypothesis, then it is type 2 error. Next. And this is a situation where you can see that type 1 error and type 2 error hypothesis is false, and you fail to reject the null hypothesis. So the significance levels are different. For type 2 it is 0.2%, and here it is 0.05%, or it is less than 5%, and here it is 0.2, means 20% or 2%. Next, please. So this is basically a diagram to show that the hypothesis is a statement or idea or assumption of the researcher or scientific inquiry or of any real situation. Then you develop the null hypothesis, alternative hypothesis, hypothesis test, and then statistical test, parametric test, non-parametric test, here Z test and T test. Mostly T test is applied, and here chi-square test are other tests, U test, H test, these are also used, but we normally focus on the chi-square test. Next please. So I have already given that false positive is type 1 error, and in my opinion, this is a serious error as compared to the type 2, but in certain studies and somewhere, but I have rechecked it from the Quora that type 1 is serious when there is a false positive, and when there is a false negative it is error, but it is not as serious. Next please. So this is a kind of new concept, and I am not dealing with this. So here the large people will understand a false impression, and they will understand that this is the truth, that it is not actually truth. Next please. This is a hypothesis how you will generate drinking sugary drinks daily leads to being overweight. So you become fat if you take a sugar more. Sugary drinks. Next. And then you have to try to test it, and if it is true, then you will detect then it is type 1 error, and if it is not rejected by it is false, then it is type 2 error, that is beta error, and here it is alpha error if you are rejecting the true null hypothesis. We don't know the actual situation, but even that statistical manipulation, statistical calculation can lead that you have rejected a true null hypothesis and you fail to reject a false hypothesis. These are type 1 and type 2 errors. Next. Yes, this you can see that this shows that 4 times it is dangerous if you are making the type 1 error or alpha error. Next please. So this is a chi-square test, and this is basically a formula for the undergraduate and postgraduate. They should remember x square equal to summation O minus E square upon E is expected value and O is observed value, and this is a chi-square distribution of the population, and this is degree of freedom, which is normally n minus 1. Next please. So this is a chi-square formula, I have already explained. Next. Yes. So ultimately we will have null hypothesis ultimately and alternative hypothesis that it is unequal, equal, and this is the rejection area and this is not rejection area or fail to reject area. So your data if falls here, then you will not reject. Next. Yes. So these are the table already, and you will compare the calculated value with the critical value or table value, and if the calculated value is greater than the table value, then you will reject the null hypothesis. And here it is a situation where calculated value is 6.3 and the rejection value or the table value is 9.4, so you will not reject the null hypothesis. So that is a common question, that if the table value is less, then you will reject, and if it is more, as in this case, this is calculated value and this is table value, you will not reject the null hypothesis or hypothesis, and you will say that the significance level is not as important. Next please. So this is a t-test, which is also a parametric. The chi-square or non-parametric. This is a parametric test. This is the formula, and this is kind of calculation, and ultimately the same is. And for the calculated value, we use the word p. P means probability of making mistake. So if it is more than the table value, then the probability is less of the mistake, and if it's less, then the probability is that there is some kind of chances, more chances of the mistake. Next please. So thank you very much. I think we have given the null hypothesis, alternative hypothesis, as well as the chi-square test, t-test, and their calculation, their formula, and type 1 error, type 2 error. Type 1 error is serious, please be careful, it is equal to the false negative, and p value is considered 0.05 or less than that, then you will reject the null hypothesis. If you are new on the Dr. Hussain Bashkulaji YouTube channel, then please subscribe it, and in the comments I will like that you should have any comment or any query. We will be happy to answer that. And this was basically a focused lecture of community medicine, public health for MCPS, Fcps, MPH, PhD, and even the MBBS and other interested people in public health. Thank you very much.